Okay, so today I am determined to fix what we messed up yesterday. We were trying to fix our moving 2 grids away, right? So we can move to this grid, then drop everything in this grid and continue to play. It should have switched to white's move there, which I think is part of the problem. But what was weird was if we... well, I guess this makes sense that if we would lock in this area, we would hit enter and it would go to the next direction in the grid, which is nil, which is why we crash. So that makes sense. But what doesn't make sense is if we are right in the middle, if we're not grid 2-3, but we're actually grid 3-3. Let me just... How do I replace? Find and replace. Option Command F is replace. So Option Command F. Replace with grid 3-3. Find all, replace all. Save it. So watch this. Now that if we were to drop all of our spaces, or all of our... What the heck? That was very messed up. That let me drop... So this is what I was so confused about yesterday was... Why... Wow. That is so jacked. Okay, so I think the move to do... If you take a look at what our logic with our inputs look like right now. Let's look at our move type move logic. We've got, this is the placement. Here's some move type move. So it's under a mouse press. But then we're kind of toggling it based on these different booleans. Like, okay, if we're not origin move locked, we have to do this. If it's more than 6 occupants, we got to do something different. If we don't have stones in hand locked yet. So my idea for this is to kind of rehaul all of this move type move logic, because something's getting set wrong and it's hard to maintain when we're doing these booleans, and it just gets... See how many times we're copying this stone assignment, and especially when we lock in the directions, it's the same logic. All we're doing, pressing down, should just drop a stone, update its stack order in the selected move grid, and then able to move on or not move on, depending on its grid order, which we also need to kind of limit. So like we need to say something like, if the move we're on is about to be the end of a grid, so like if our direction's up and our grid row is 1, then we know we need to swap characters. We need to actually force the active player to drop all their stones, so that they can swap the player, so that we don't get that nil indexing problem on the grid here. It's just that something's going wrong with the Boolean switch off logic here. So we kind of need to redo this. But I was thinking, okay. So we're doing a move rehaul, right? Now we're gonna have, instead of using these booleans of stones in hand locked, first movement origin locked, first movement stones dropped, instead of having those things, we're gonna make something called like a movement order, movement stage, because it's the stage of the movement we're at. Does that make sense? movement event, maybe? Movement event kind of makes sense. So movement event 1, no. We're just gonna update the movement event, right, to be these different things. So like, movement event 1 and 2, 3. We need, I don't know how many we need, but we need to be able to signify, hey, if down is pressed, then ask what move event we're in, because if we haven't even locked in our stones in hand yet, pressing down shouldn't drop a stone. But if we're in a movement event 3 or 6, which is the time we drop stones, we would do something there. So we kind of need to count this out. So this would be currently, when we switch to a move type move event would be 1, which is just highlighting a legal move. And when we do that, we toggle our movement origin locked. So movement event 1 is from when movement of origin locked starts as false, and once it becomes movement origin locked, it goes to movement 2. That might be a good way of representing it, or do we represent it before movement origin gets locked? Because movement event 2 would mean movement origin's locked. So I think we have something called like a no move locked or something that this one can be. Movement 2 would be when we're movement origin locked. Okay, this is making more sense. Let me see in our play state what we've got something called like no movement locked or something. Maybe not. Maybe not. Anyways, movement event 1, you would have to select legal move, highlight. Okay. Once you select it, we origin move and lock. Then you have to like lock in, decide how many stones in hand. You want to take them all? If so, just hit enter. If you want to drop two, then hit enter. So that's our movement origin locked, and that would be how many stones in hand or in movement origin. I'm just gonna say in hand, honestly. Then once you decide how many stones in hand, you have to select legal move direction, which will lock in your direction. Now, that should lock in and I'm using the booleans that we kind of are currently using to transfer this, so that we can see a kind of flow chart, so that we know how to build this event thing, because it should progress through all the steps. Every move will have these steps in order up until, some optional moves. Because you can move one grid only, and that would probably end at a move event 4, I think, because once your movement origin locked, you decide how many stones in hand, then you hit enter, and then that will allow you, that's stones in hand locked, which will allow you to select a legal move direction. And that legal move direction will allow you to lock in your second movement grid, second movement grid locked, at which point you have to decide, actually just drop at least one stone. And then once you drop at least one stone in second movement, hitting enter, actually no, this is first movement locked. because the place we originate doesn't count as a movement, it just counts as deciding how many are leaving the spot. And then this would be our first movement locked, where we would decide to drop at least one stone. And dropping at least one stone will let us, once we hit enter, we would actually become, and this is where we do things a little different. We don't have to lock in the movement here. We just have to lock in, or we don't have to lock in, I don't know how to explain that. We're getting rid of the legal move process, because at some point to find the legal moves, we have to do something, but once our direction is locked in, our next move has to be in front. It has to be in the same direction. So once first movement is locked, you drop a stone, then you hit enter, then your second movement becomes locked, then you have to drop at least one stone. See, this is looking already like an easier thing to keep track of, rather than these booleans in a bunch of different move type move, if down was pressed or up was pressed or enter was pressed. So now what we can do is have a play state where we say, if it's a move type move, we start out at movementEvent1, move type event 1, and then we can go make sure we do all of our no move locked in logic, which is, I think, actually not movement origin locked in our code. But then we can basically in our play state say, hey, if up was pressed, then depending on the event number it's actually at, that dictates what actually happens, because first movement's still locked, second movement's locked. All of those do the same thing. If you press up, for example, which would just pick up a stone if you have dropped a stone in the grid already. And then down would drop a stone only if you have more than one occupant, or actually more than 0 occupants, because you can drop them all. Gotta drop. So drop at least one stone. Now once we lock in, this is like our first dark green box. And then second movement is actually our second dark green box. That kind of makes sense. Okay. Now, once we are in second movement locked, that's where we would put the dropping or picking up a stone in that grid. Then if we hit enter in that event, we would lock in our third movement, which would be our third green box, our fourth total space, and the most we can move is 4. So our fourth is actually going to be the same. So we drop at least one stone. This is our third dark green box. And then movementEvent 7 would be our fourth movement locked. Okay, we need to add some specifics where, like, if fourth movement is locked, then we need to allow us to drop the last stones. Drop all stones here. And then press enter, which should change the player. So it looks like we've got 7 different move type events. So in our code now, we were trying to handle the differences of that in one, actually not in one spot, but it's just so messy because we're kind of like, where is all the mouse pressed logic? It's like it's all over the place. Some of it's up here, some of it's down there. And then where's all the pressing up logic? Well, there's some here, and then there's some here. And then in order to see that, you have to look over and see what Boolean we're flipping, and then remember what Boolean we're flipping at what point in stage, and remember what's happening at this, because it's just hard to understand when I'm doing all this stuff and looking at all this type of code. But I think if we organize it like this is going to be so much better. We only register key inputs depending on which event you're in. So like here, now let's add all the inputs that should be allowed. Well, if you're no move locked, what would happen would legal move highlight is true upon mouse over. Okay. We need to detect clicks. We need to detect clicks, which actually we would detect clicks outside of these, so we don't have to detect clicks for each event. We actually detect a click, and then based on the event, we do something. So click detection would actually go outside, where we would have like click detection, and then have all the if these events. Then we would have if up detection. Then we would have different things to do for all those events. But this is actually not quite right. We need like it's like I'm trying to build out in somewhat pseudocode so I can kind of see what the flow of it would look like. So like if down detection, we would do a bunch of different things based on the event, right? And then if enter detection, right? Now we would need something because I don't like how we have to ask every event. You know, we're going to have different event logic depending on any click detection, but I think we need specific click detection based on what event we're at. So instead of doing it like this, I think we should actually do it like this, where we have all the events. And then we say, if event's 1, then if up, if down, if clicked. And we would only need these if it's applicable for each one. So we would kind of go down, but to kind of build out in pseudocode so I can kind of just wrap my head around it. This is working for now. And if enter is pressed. So we would have the specific detection upon the movement event. Okay. So, and we wouldn't need all of these. We wouldn't need if up and down is clicked for every single one. I'm just trying to kind of visualize what this code would look like if I were to commit to formatting it this way. I think this looks a lot cleaner, because since we're going to be incrementing move event at the end of these, we're going to say move event gets, you know, set to 2 at this point. If enter's pressed or whatever it is. This is just, I think, a cleaner way of handling it. So what we can do is kind of build out a mock one. So like, look at the difference here. Now we're in our play state. We're seeing what event we're at. And then we've got a certain amount of input detection waiting for that if it's pressed. And anything outside of this block will just update things, such as rendering legal moves if our mouse is hovering over it and it's a legal move, you know? Versus up here, if we just do the detection once, then we still have to do specific logic for each event under every specific detection for each event. So this is looking cleaner to me, and this will get cleaner as we take them out. So let's walk through the types of detection we need in a move event 1. So we got no move locked. We only need click detection because we're just trying to select our legal move highlight grid. So the thing we need to do is render legal move highlights upon mouse over. Okay. We'd probably need to we would actually need to set legal moves to be orthogonal stack controls, because you can only move a stack that's in your control. So the first thing we do is set our legal moves, then we render our legal move highlights upon a mouse over. Then if we click it and it's a legal move in there, we need to lock in our movement origin. So like, you know, I think because of our last crash when we were trading and incrementing the move locked row, let me think about this. Yeah. Clicked and a legal move. Then we need to lock in our movement, origin, row, and column. Yeah, so as soon as we click, we lock in our movement origin row and movement origin column so that we can detect new legal moves based on that. And then we place, you know, we need to place top 5 stones in hand. And we don't need to run stack order or stack control on any grid just yet because we haven't locked in how many we drop. So we just need to place the top 5 stones in mouse stones. I mean, in hand makes. I know what that means. So in move event 1, we click on a legal move. We will pick up the top 5 stones. If we have stack control, which would be a legal move, we lock in a movement or movement origin row and column, and then we go to move event 2. Is that right? Now, move event 2 decides how many stones are in hand, and we don't need click detection for this. We just need if down will be first, because you can only drop some if you've got some. Well, you can only pick some up if you drop some, so we need to drop stones. This is a pick up stones. And then if enter is pressed, that would be a stones in hand locked. We might be able to get rid of that. We might be able to get rid of that variable altogether. If enter is pressed, we need to lock in our stones in hand locked. We might be able to get rid of this. Move our movement event to 3, but not before we update stack control of the grid we moved to. No, of our movement. Update stack control of our movement origin grid. Okay, that's an occupant class. And we need to update stone control just in case we dropped a lay stone, or because we need to be able to nullify that as a legal move for any other move type moves. So we do that. We update stone control for our movement origin grid. And maybe we only do this actually once upon. Yeah, maybe we do this once. Maybe we do this once upon end of turn. Because otherwise, we're going to be updating a grid. Yeah, we could potentially use the same line of code, like, here, and then here, and here. But then we can just run one code. We could say, hey, for grids movement origin, first movement grid, second movement grid, third movement grid, we need to update stone control and stack control once our turn is up. Or we do it as we do it, which honestly can't really hurt either. So maybe we do that. Because then we don't have to save another variable about every single grid we're at. Actually, we kind of do, because this is going to be movement origin row and column in our grid 2D array, so we're gonna have to do it anyway, kind of. So yeah, maybe we just do it when we do it. When we modify the number of stones in a grid, we update stack control and stone control so that it's always right. Then we switch to movement 3. So yeah, we don't need click detection in a movement event 2. Movement event 4, where we've got our decide how many stones in hand. Oh, this locks in direction too. No, it doesn't. Once we hit enter, we lock in our hand. Yes, okay. So now we need to render orthogonal possibilities. So like, we didn't need orthogonal up here. This is actually set legal moves. On stack control. And then this is our legal orthogonal moves. Because we can't move orthogonally until we decide how many stones we're going to be moving, which we have to lock in this movement event too. So this is set legal moves. Orthogonal spaces. And there's a caveat there. And not capstone. capstone, standing stone, or end of grid, because we have to check that too. That's what's getting us the nil bug right now, is we're not checking that grid, because if we're moving into a direction, that doesn't have any more space, we have to force the player to drop all the stones there. And I don't want to just place it for them by themselves and then it'll switch the player's turn, because if they didn't realize what was happening, I think it'd be just kind of messed up that it would happen so fast and they wouldn't realize. Because as soon as you would lock in a second direction, if that second direction is at the edge of a grid, it would just delete all your stones, or drop all your stones, and then change the player turn, which I don't want to necessarily do. I want the player, if they have to drop all their stones in that grid, have to manually drop it in that grid and then lock it in to switch the player, because I think that's more polite, I guess. But in movement 4, movement event 4 is where we have to drop at least one stone in the first dark green box, which is our first movement locked. Now, we set our legal moves based on orthogonal space, at a capstone, standing stone, or the end of grid. Then we need to check up or down, that's right, because we're only worried about dropping stones. We're not worried about clicking here, so let's just make sure we do this in the right order. If down, drop. If up, pick up. And then if enter, then we go to first movement stones dropped. But we don't need to do that anymore. We can actually just say if enter's pressed, then it'll lock in second movement lock. So second movement lock gets true here, I guess. No, I mean, we're trying to get rid of those things and only use the numbers to kind of segue this movement. What do you call it? Like order of movement rhythm. I don't know what you call it, but this would be, we would update stack control for this. Not the movement origin grid, but the first movement. And before we were doing this part, I'm pretty sure we were doing this part based upon a move locked variable that we kept updating. Now, what I'm suggesting for this update, so we don't crash like we have been, is to just keep all of the moves separate. So like this is, instead of updating stack control on move locked row, and move locked row, and move locked row, and then updating move locked row here, I just got bugs last time. So now we're gonna save different values for the different grids, and we're only gonna assign it based on the grid. We use a little more memory, but I think it's safer that way, and I'm just sick of it crashing, so I'm wanting to lock in this feature, you know? So if enter's pressed, we move on to movement 5. Movement 5 is where we have to drop at least one stone in the second box. So we do the same thing. If down, if up. This is helping me visualize it, you know? Okay. Drop, pick up, and then same thing here. Update stack control, stone control, because we're modifying the number of stones in a grid. So we would update this second movement grid in the 5th event. And then having a document over here we can reference for all the numbers and notes is going to be really nice. Yeah, I think this is looking much nicer. This is looking so much nicer, so much easier to maintain, because now there's like, it moves. It goes from here to there to here. It's not based on the input and the Boolean for what part of the move we're doing, so it's so much easier to maintain this way. So we hit enter in a second movement locked. That means, and we've dropped at least one stone. We're locking in that second movement, and then we're going on to movement event 6, which is a third dark green box. Yeah, a third dark green box. And we do the same thing. We drop the available stones. We pick up the stones we've dropped if we want. Down is drop off. We don't need click detection. If enter is pressed, we need to lock in our stack control of our third movement grid. See, and there's the programmer part of me sees all this, where it's like, look, all we're doing is the same code. We'll drop a stone in a certain grid. Like, the thing that's changing is the grid that it's being dropped in and being picked up from. I think it's okay to sectionalize it like this. It'll make it easier to debug. And then we lock or update stack control, stone control of that third dark green box. Then we switch our movement event to be equal to 7. And movement event is 7, means we got fourth movement locked. And that means up should do nothing, because you can't pick up any stones. Actually, yeah, like we're not going to allow you to pick up stones because you have to place the stones there. So we'll just do that. If down is pressed, you drop. And then if enter is pressed and mouse occupants is equal to 0, meaning we've dropped all of our stones, then we would reset variables and then switch players. Do our swap player function. This is looking so much cleaner. Yeah, this is so much easier to follow. Okay. So now the only thing to do is to implement this, where instead of doing all of our move type move logic randomly depending on inputs and booleans, we have a more streamlined flow of what we're doing. So, where do we start? I guess we start by getting rid of all of our move type move logic, right? It's like what I really want to do is kind of quarantine all of this old code, give us a big enough break where we can add in the new code, and we can kind of copy and then copy features, make sure we've got the. We should write the features, but what we're going to do is have the features copied so that we can look at it while we reference the logic to make sure we're not forgetting anything, like incrementing the mouse stone occupants when you pick up stones, because that's not something I wrote here upon pickup, you know. So we'll just be careful about that. We won't physically copy anything into our new order, but we will physically copy stuff into a different section so that we can build it out and make sure we don't miss any functionality. Yeah, okay. So I think what I want to do is basically just quarantine all of our move type move logic. So we can kind of keep this because this is just updating our mouse stone to be our mouse position. We've got our place logic, which is working fine, not crashing. I thought we weren't doing this. I thought we weren't nullifying the grid. Hold on, let me look at something right here. Okay, this is what we're doing. If we nullify the mouse position so that we don't... Okay. We left this off because it was crashing the debug when we'd go off screen, because when we're printing a value for an occupant that is nil, once we go off the screen, it would just crash. So when we don't have debugging logic to be turned on, we can turn it all off, turn these back to nil, and then it'll not highlight, for example, the rightmost grid in a move type place if your mouse is all the way to the right. Because right now, if you move the mouse even off the grid itself over to the right, it'll still say that that occupant is selected, which we don't really want. So this is sound effects, which is sound effects for switching the move types. Now, what we can actually do better than this. Yeah, we can do a ternary operator here, which I won't do just yet, but we can make that cooler. Update mouse stone position, that's fine. This is fine. This is fine for stone select and a move type place. That's fine. Okay. So we do need click detection for move type place, because that's what actually highlights our actually that'll place a stone. That'll place whatever stone is selected for whatever player. And then if a move type moves, so here's our first move type move code that we can kind of get rid of. By get rid of, I mean to kind of segregate it out. So this is a move type move, and we're clicking on a legal move, and it's space with 5 or less occupants. So this is basically just like move one. So let's see where we can take this out. Okay. So what I'm gonna do is make sure this move type place has an end. And then I'm going to copy this out of here, all this move type move logic, which ends right here. So if I cut that, we see that that function ends properly, and then we can go ahead, and I want to add a bunch of space here, and then put this over here. Comment it out. Actually, we'll leave it, look, I'm just gonna say old code, old code, old code. To kind of signify that this is where the old code starts. We're gonna kind of segregate it here while we reenact it. So here is more old code that can just be scooted up here. So we would need the end to that. Okay. Okay, there we go. So here is more old code of our move type move and not stones hand and locked. So now we're going to be controlling this through the number system, through that move event flowchart. So all this move type move detection is going to be replaced with that new outline we just outlined. See, this is more move type move. And then that should be the last of it. Now, this is technically the move type move logic, because this will only get updated. These Lego moves only get updated in a certain movement event. So that's in a move type move, so we can keep it here as part of our old code. All of this legal move detection, we need to move. We're moving it because we're not going to be using this if stones and hand locked and not first movement grid locked. Because what this is really saying is it was a way of us to step through only certain events. So stones and hand locked and not first movement grid locked means we locked in how many stones we have, but we have not dropped those stones into the first movement grid yet. All right, we haven't even selected our first movement grid yet. So we have to actually update legal moves for what our first movement grid could be, then render those highlights, then wait for a click. So we can take all this out. Movement origin locked. This is the same stuff. Yeah. Legal moves, placement highlights. Okay, so we need to take this out of our old code section. So this is like the last thing. So what we can do is take this chunk. Oh no. Oh God. That's a shit ton of code, dude. Okay. We need to take this thing out. We need to be able to take this nested for loop, place it outside of our old code, and this marks the end of our old code section. So we're going to be replacing all this with this new structure. So look at how much this is that we've done already that we need to refactor. It's a pretty sizable chunk. But if we do it that way, it's going to be so much easier to fix the debugging and ultimately get to the end of this feature. So if it's a move type move and it's player one, okay, so this is See, we need this under an event too. Because what this is doing is assigning legal move status. Well, it depends. If it's a move type place, we're assigning selection highlight status based on the mouse location. And then this is where, actually, hold on. How are we turning the selection highlight false if we're not highlighting over it? Oh, this is what it is. We only render the legal move highlight. This is jacked, man. This is jacked. This is so weird that I did it like this. See, everything is split all over the place. Because we've got some more move type move stuff hidden over here. Like this. Well, I guess that's just for render, so it's okay. But I am kind of confused where we're actually flushing that legal move highlight. Or selection highlight rather, because that's the red color for our move type place. And right here, we're just saying, hey, if it's move type place and our mouse is over that grid, oh, get true, otherwise get false. Okay, so yeah, only selection highlight if our mouse grid is equal to our current grid's location, mouse location. Makes sense. So I would just say selection highlight. That is under mouse location, or if over mouse location. Cool. Then, if it's a player, this is something else we need to do, or we need to say if move type move, then depending on the player and depending on our mouse location, if our stack control, so this is setting legal moves for the first movement. This is legal move. So look, this not movement origin locked means we haven't even selected our movement origin yet. So if we haven't selected our legal move or movement origin yet, we're in a movementEvent 1, which is no move locked. So if no move locked, then we set legal moves based on stack control. And we should be able to I don't get why. It makes sense we'd have to kind of, well, no. Legal move highlight is false. So this is like only render the stack control that you're over. Yeah. And because we toggle the rendering based on the highlight, but we should toggle the rendering based on the mouse position and based on the legal move status, just like we do for selection highlight here. Which, how is that different? Because this is just flushing okay, so it's like we're setting legal move here, but then we're not using anything to be, no, yeah, we are using it. We're using it down here. We're saying if our mouse grid is in a legal move, then set our legal move highlight to true, otherwise set it to false. So I guess we don't really need this else stuff. Let me see if turning off this else stuff. Let's hope we didn't screw up any of our old code. I probably did. To run this. See if this, well. We'll keep it there for now. I'm just gonna do another line here that says old code. And then we can kind of evaluate it as we add those functionality in testing. So, okay, so we've got this chunk that's old code, needs to be replacement, and then we got this chunk up until, Jesus. Oh my God, here. So we're trying to redo all that today, refactor that. I don't think it's impossible. Let's get going. So we'll put the new code up here. So right up here we've got if mouse pressed, and move type place. So this is all placement, which is fine. So we can say that this is placing. This is placing a stone in empty spot. The placing move, because we can kind of collapse this. Yep. So if the mouse button is pressed, we place a stone in an empty spot if it's a move type place and the grid isn't occupied. Okay. So we've got, so silly, there's two things you can do in this game. Place a stone, or move a stack in your control. This is all the code for placing a stone. And then this is the code I had that was busted and incomplete for moving a stack in your control. All that plus this. And it was incomplete, we only had 3 moves, not 5. So that's kind of the hilarity of the 2 steps of this game, because one step is done just like that. And then we have the real step. Like I said, the meat and potatoes. So we've got placing a stone in an empty spot. So now, here's where the magic is going to happen. If it's a move type is equal to string move, then this is where all of our move type stuff goes, just like our move type place goes here, except we actually have a bunch of new things now. We've created a movement event that can go up to 9. So we have a variable called movement event, and if movement event is 1, meaning that's where it starts, so we would have to say if an event is 1, let's be verbose about it. Movement event is 1. Then do all your movement 1 stuff. Now we need others. Else if movement event is equal to 2, do that. And if movement event is 3, do this. Movement event is 4, do this. We need what, 7 of these? Else if movement event, oopsie, equal to 5. This is gonna hopefully help prevent that debug doing something when we didn't want to, and easier to track the order of operations for when we press a button, what the heck is actually happening. Because now, only depending on our movement event, is it gonna do anything different. So, now that we've got all 7 movement events, yep, we need to ensure that we have this initialized so it's not garbage. So movement event here, I guess, will be before all this junk, I don't know. Movement event gets equal to 1 upon reset, and upon player swap reset. So that the next player can start from a movement event 1 as well. Okay. What's next? We've got movement event. Let's pull up our notes here. We're gonna go double screen programming here because it makes sense to. Hey, where did my whole page go? Here. What the heck? What are you doing, man? Okay. Here we go. Nope, not what I wanted. There we go. Okay, cool. So now we can actually look at us moving on up. Movement event 1. So let's copy over our note, which is movement event 1 is select a legal move highlight. So in select a move highlight, actually let's just put this in here so we can kind of keep an eye on it. If a movement event is 1, we need to do all this stuff. Okay. So we need to set legal moves upon stack control. So I guess the question is, do we go back to our old code and copy over the stuff, or do we try to do it from scratch right here, right now? I'm kind of leaning towards the scratch, so we don't copy over any old bugs we made. I'm just going to use the restroom, and I'll be right back. So I'll leave this going so you can watch this, and I'll be right back. I just don't like stitching the videos together in post. I just like posting the whole stream, so I'll just be right back. Let's get to it, man. So we've got a couple of things to do. If movementEvent is 1 and it's a move type move, part of me wants to see if we can just turn off all our old code so that we can get to testing. We should be able to turn off all of this right here. No. No. I want to be able to toggle all this off. So I guess let me just delete these end brackets. So that we can toggle it all off. Right here. Okay, okay. Okay, we can. Okay, let me see. Okay. Okay, perfect. Oh no, we still need to turn this off too. This is still old code, this is still old code. This is still old code. Old code, okay. Okay. And then we need this off, which is actually this only goes to here. Nice. Okay. Now, you know what we should do is just put these two up here. Uh-oh. Oh no. Okay, that should be okay. Okay. Is that right? Maybe we just put the end up here. And then this old code is kind of sequestered off over there. Okay. Then maybe we should add this to be up there too, so we don't have to go searching on the other side of the world for it. So we'll put this and this up higher. We'll combine all old code places. Okay. We'll put it up here. Oh my god. Okay, nice. Really? Is that all we're keeping in our play state? It's just that much? Might be way too ambitious to get this done in one day, but I wanted to do it. Let's see. So, what this does is this will render the selection highlight for the placement. Let's keep things separated. So this is just placement highlights. If it's a move type place, go ahead and do that. I guess maybe legal move highlights. That makes sense, because legal move highlights would be a selection highlight versus move locked highlight, or whatever we had. Legal move highlight or move locked highlight. So move locked highlight is the dark green, legal move highlight is the bright green. So we've got our legal move highlights down here. We've got our Move type move detection up here. We've got our place up here. Cool. This is, see, like now with the grand scheme of looking at it, it makes more sense. Like, because we can kind of close this stuff. This all stuff that doesn't really depend on the move type. So if you look at it, it's all closed like this. Actually right here. Yeah, nice. So like those are all closed. This is our main logic for our move type move. And then this will be, God. Yeah, then we get to the render. So let's see if we just crash right now, because I wouldn't think we would crash. We just wouldn't really be doing anything at the moment. Well, we're 06. Yeah, this is all. This at the moment is our working block of pseudocode, which we can actually, instead of turning that off, we can just mute this stuff so it doesn't do anything. Now it should crash. I say that. Okay, doesn't crash. So, can we switch to move type move? Yes, we can. Can we do anything in move type move even if we have control, stack control? Doesn't look like it. Okay, this is what I expect it to be. Now let's get rendering on our screen here what movement event we're at, because that'll be helpful. So we will say in our place state, in our rendering, what don't we need? Move locked row, that'll be handy. Stone occupants will be handy. Stone control, stack control will be handy. So we'll just add it. First movement stones dropped. We won't need that. So let's put it here. We'll put what I say we were going to put here. Move event. Movement event. So movement event number. And then we concatenate with a string of an integer that is our movement event variable. Cool. So we should be in movement event 1 in a move type move, and we should be able to switch back to move type place and place a stone, no problem. So move type move, movement event 1. Yeah, that's fine. And we should be able to place stones, no problem. We should be able to place any type of stone, no problem. And we can't place a stone if it's occupied. That's all looking like it's right. And move type move, clicking doesn't do anything, but stack control is populating correctly. Stack control and stone control are both populating correctly, it looks like, which is good. We can take off this move lock row because we're not going to be using that anymore, which means we can put our movement event debugging at line 5. Now, let's get to adding that functionality. So the idea is to add things back in piece by piece, and hopefully we won't crash as we go along. And hopefully have perfectly pristine logic for each movement event. This is a lot of work. It's a lot of work. Good news is we already did basically all of it. We just need to do it better. Okay. Okay. So, upon a movement 1, we need to set legal moves upon stack control. So, we need to cycle through the grid because we need to be able to have access to the index that our mouse is over if it's in stack control. So we need to have a for loop here. I gets 1, comma 5, do nested for loop So we have all our rows, all our columns. Now we're trying to modify the grid at our ij, but only if we're trying to make the grid at our ij a legal move, only if our mouse position, only if our mouse y, actually our mouse x, is that right? Mouse x is row and mouse y is column? Yeah. Yeah. Mouse x grid gets no. It's we're checking our mouse position, so we say yeah, we need to set legal moves upon stack control is different than rendering legal move highlights upon a mouse over. So we're just going to switch the legal move if our mouse is over it. So how do we do that? If our mouse grid is equal to I and our mouse Y is equal to J, then the legal move in that space is true. But mouse grid would have to be, so mouse grid I and J and that grid, the grid at mouse grid, mouse, and it's row and column, so mouse X grid, mouse Y grid, dot occupied, which is a field of our occupant. We'd have to make sure that is false in order for that grid that we're over to be a legal move. Now, we're not actually, there's two ways of doing this. We used to be doing this by saying, instead of legal move gets true, we say legal move highlight gets true. And then we say else, meaning if our mouse, it'll actually falsify all legal move highlights for all the grids if it's not currently under our mouse, which is what we want. So we don't really have to determine legal move here. We can literally just, actually, yeah, if we click in a legal move, we do. So we would want to say, yeah, we need to set legal moves upon stack control. So we need to cycle through all the stones, and we need to say if the grid at this location dot stack control is equal to white, that's player one. So we need to say if we're player one, then if our stack control is white, player one, and if our stack control is white on any grid, then we need to give that grid a legal move. And that's going to determine whether or not we can click on the space. It doesn't have anything to do with rendering, because we're handling the rendering right here also. Then this legal move is going to be equal to true, and if stack control is white set our legal move to true. And we don't have to falsify legal moves because they should be false upon a knit. So we should get away with this. So if player 1, else if player 2, then if stack control's black, then legal move is populated for him. Or her. So we've got right here, set legal moves upon stack control. Right here. And then we've got render legal move highlights. And this is actually, what do we call it? We call it selection highlights. No, we don't, because this is a move type move. So yeah, this would be a legal move highlight. So render legal move highlights upon a mouse over. So we're doing that right here. Render legal move highlights upon a mouse over. So we set the legal moves. We set any legal moves. Then we render the highlights upon a mouse over. Now we need to add, if clicked, so this is movementEvent1, so right here. If love.mouse was clicked, or what was it? Placing a stone in an empty spot is a function love mouse pressed XY button. And if button is 1 is a left click, so we'll say right here. So in this function of mouse pressed, we're going to say if the grid at our mouse location, which we're updating every frame, we can want to prove that we're updating our mouse tone every frame. This is interesting. We don't move we just move our members 1. No, we move every member. Okay, this is maybe not optimal, but yeah, every frame we're moving every member to be the X position of our mouse stone. So if our mouse X grid, mouse Y grid, where our mouse position is, this is a lot of work, yeah. We're just still on movementEvent1. If we're clicked in a mouse event 1, movement event 1, if the grid we clicked on is in fact a legal move, meaning we had stack control, then we need to take 5 stones out. We need to take the top 5 stones out. So I might glance over at our logic here for this. I'm kind of curious where this stack control legal move is and how we did this. Oh my God. You know what? Let's continue to keep doing it. You know, we're doing it, so let's continue that. We're in a movement in event 1, so we should be rendering legal move highlights. We should be setting those legal move highlights. So we should be doing exactly what's on screen over here, rendering whatever's stack control, rendering that green, and then we're working on our mouse pressed function in that grid, but because we ate. Okay. For now, let's just switch to movementEvent 2 upon clicking to test that. movementEvent gets 2 if we click an illegal move. So let's see, we should be rendering legal moves. Let's see. Should be move type place. We are move type move, and we crash. 418. What's happening, bro? Moused. Move type move. This is jacked. We messed up our mouse X grid, Y grid. But it's not rendering on the spot that's occupied, which is right. So we just need to swap this. It's actually our Y grid is our row. That makes sense. It's X grid column. That makes sense. So right here we need to set the mouse Y grid and mouse X grid appropriately. And then anytime we render where our mouse currently is, it's Y grid then X grid. We just have to remember that because it's row then column. A is row, X is column. I guess that makes sense. So let's see if we are rendering those moves appropriately now. In a move type 1, move event type 1. We're rendering our placement. If it's not occupied, that seems to be working. Now notice that all these are legal move false, which isn't necessary. We don't need to make these legal moves because we're asking if we click on a spot and it's empty, then go ahead and put that stone there. It's not unless we're in a move type move where, God, this is still backwards. How did we mess this up? Maybe we did this backwards? No? Let's just swap this again. X grid, Y grid. I won't worry about this one just yet. I just want to get it working. Okay. You're messing with me, man. Does it matter which one these are? Mouse X grid is I. Let's put mouse Y grid at I. Does that wouldn't make a difference? They're just going through each one. If our mouse grid, oh yeah, let's try that. Mouse Y and X. I think that's right. Okay, that seems to be working now. So, actually, this is completely wrong. This needs to only render if we've got stack control. So this is, legal move is false, and yet we're rendering stuff. It should be a legal move if we've got stack control. So let me see if we've got stack control. We've got stack control, and yet we're still rendering these things. So how about? Oh, we're not setting. Every grid should be legal move false to be set out with. Then I'm saying, if any grid has a stack control, then that grid's legal move becomes true. Also, if it's player 2, stack control's white, legal move. So stack control should be white and we should be player 1, right? Player 1 is white. We've got stack control. Why don't we highlight it? Bro, what's happening? We're doing this upon not being occupied, but we need to do this upon stack control, which is the problem. So we do this based on stack control. So if we have stack control, and this is actually, yeah, Y grid, X grid. I think that's right. Let's see. We should only render exactly where we have stones. So, we need to do it based on player. So, player 1. Actually, we can do this. Yeah, we can do this here under our player logic. So, if player 1, set our legal move to true. And if player 1, if our mouse grid is Y, and we have stack control, then go ahead and render our legal move highlight, and otherwise don't. This is checked. Okay. There we go. Then we need to do the same thing. So like stack control, that expression wasn't really an expression, that was just a string. So we have to compare it. So this is if player 1, so if stack control is white when you're player 1, then the legal move is exactly where you've got stack control, no legal moves anywhere else. And then we need same thing here, else if stack control is black. Then after we set our legal move, we would just do this. If our stack control is black, then we get a legal move. Otherwise, it's false, on the render at least. And then we can take this out, because we do it for each player. And that's our nested for loop. Now, let's see if we're rendering the proper legal moves. Sorry. 75. There's an end here. We don't need this end. Okay. Is that right? Yeah. Okay. Let's see. We're almost done with move type 1 out of 7. We'll keep chugging along. Yeah, buddy. So, legal move only gets populated there. Let me just place a couple other stones and make sure it is working right still. Okay. So, move type black. Only black occupants, only black stack control should render as a legal move, which it does. So we can move any of these stacks. This is great, man. Okay. And then if we are white, what the fuck? We need a flush. I think it's because it's a legal move. we need to flush legal move before we set legal move, so that we don't come across that problem. Because once we highlighted them, yeah. See, we're doing if we've got stack control, but we're not saying otherwise, falsify it. If we don't have stack control, we're no longer a legal move, which will turn off the rendering for those opposite team ones. And we need to do the same thing over here. Stack control is white, and it's a legal move. Else we don't have stack control, we are not a legal move, because we have to flush those so that we don't accidentally trigger a legal move in one player and then come back to it and have it still be a legal move. So we are actually going to falsify those here. Okay, let's see if that works. We're going to place a bunch. Okay. Black move. Legal move only on stack control. Now, all of those should be legal moves, but now when we place a stone and turn, shit, those shouldn't be legal moves. Those shouldn't be legal moves, come on. So, it's like we need we need a flush. No, dude. I thought this would mean that if your player's over it, and you don't have stack control, then it would falsify it to a legal move. It gets false. But it's not. So let's just take that out. We need to fix this. So, how do we fix this? Come on. What if we have see, it's like legal move didn't get flushed upon switching to a placement. So I think if we're in a move type place, nope. Do we have any placement logic in our movement event? We don't. So if we're in a move, yeah, because it's triggered by a move type move. Okay, so I want to say if actually, yeah, if we're in a move type move, how do we switch to a move type move? Currently, we just swap with up or down. So where is that? Where do we do that? Because we need to flush legal moves upon switching that. I want to see somewhere here. This is it. Move type was place. Okay. So if up or down is pressed, see, we don't really want to do this. I'm kind of baffled that this was so high up, because we don't want to we don't really want to do this. We would want to add this where we're in a move event of 1. Because if we're in a move type of 1, that means we haven't yet selected our movement origin grid, therefore we can still switch back to a place. So we'll put this under our move type move logic. What? I think we want to do this too. Oh God, okay. So, in our move type move, movement event 1, we are going to check for inputs. To switch back to a place state. So if we're in a move event 1 and up or down is pressed, then let's go ahead and move type gets assigned move type equality and if this is true, it'll overwrite it, so we'll put move here. If it is a move type move, then move type gets and actually, yeah, move type, oopsie. Let's say move type is equal to move and move type is equal to place, or actually gets assigned place. Actually, sorry, the ternary operator is fun. I like it. Move type is equal to place. So what this should do is when we press up and down, move type is going to be assigned into a ternary operator. So what it's going to say is if move type is currently move, then it'll set move type equal to place. And if it is currently place, it'll set it equal to move. So that's the ternary operator we just added. So we're gonna play the sound no matter what, and then we're gonna swap the place, and then we can get rid of all this. So let's see now if we can. We have to be able to we have to be able to do this based on move type place. So we'll go to our move type place logic and we'll say, not in our mouse pressed, but just, do we have any other move type place? If move type place, yeah, then we're gonna say, hey, if we press up, go ahead and ternary that move type. We shouldn't need to do this. Why is this stone occupants here? Mouse stones occupant should be initialized to 1. Mouse stones. Actually, not if you're in a move type move. Mouse stones occupants. Okay. if we're in a move type place, then if up is pressed, swap our move type. And if we're in a move type move, we know we have one mouse stone occupant. Then we're doing the stone select. So let's see if we can switch back and forth. Oh God, 238. What the heck, man? I always forget how to do the ternary operator. Where do we do it successfully? Where do we do it successfully? I know we do it. Let's just look it up real quick. No shame. You ask actually you do an assignment. No, that's not what we want. It's the and or. What do we do it? Oh, come on. This is it. So you assign the variable, and then you ask a question, and then you put the one you want to swap it to if it's false. No, if it's true, then if it's false. So let's try to do that. So we need to assign it first. Where is here? Yeah, we assign it first. Then you ask a question, yes. If it's a move type move, and if that's true, you do the assignment you want to be true, right? They just have a variable and. That should be right. Oh. No. Why does that not work? $238. We have to assign it. How am I doing this wrong? Max gets condition or expression. Yeah, this is an expression. Move type gets. If it's move type move. Are we messing this up? I have no idea. I don't get why my ternary operator is messed up. I'm always looking this up and then I Okay, so look. If A is nil, then B, but what are you doing? Let's see. If A is equal to nil, then B, otherwise C. So move type. I don't get it, man. If it's a move type move, then that. If it's not a move type move, then it gets set to move. Okay, I don't get why that's not working. It's really bumming me out. Come on, dude, come on. Do you not crash if that lines out? You still crash. You crash because we do this over here. Still. So let's not do that over here. You know what? Yeah, we don't want it here. We don't want it here. Well, we need it both places, yeah. Let's just get the ternary working in a move type move first. So if a movement event is 1, then if love.keyboard was pressed up, or love.keyboard was pressed down, we need to swap our move type. So move type gets assigned if our move type is a place, which should be true. No, if it's a move, should be true. Then we set our move type equal to place. Move type gets place. Or we put move type gets move. That should work, and we play the sound either way. Which did we take that out? We want to beep. So we'll play the beep no matter what. Let's see if we do that. Come on, dude. It really just doesn't like the ternary operator. What am I doing wrong? There's gotta be a place where we're doing this. What? It's in our old code. I don't remember where we did it. We've done a ternary operator here. And I'm losing my mind that I'm not able to do it. Let's see. For pressing help. No, it might be up here. Toggle help. Where are we toggling our help, dude? Look at this. This is a ternary. Help state gets assigned to be an expression and 2 or 1. Okay, so I think we can leave out the variable. We just say what to set it equal to. So I think that's it. So we can just say up is pressed or down is pressed in a move type place. No, in a movement event 1 and a move type place eventually, but we need to do this one first. Here we go. So look, we just need this and place or move. So if it's already a move type move, it'll be this one. So it'll swap to a place. And if it is a move type place, because this is false, it'll become a move type move. And we'll play the sound either way. So now we should be able to swap to a move type place from a move type move, but we can't actually swap to a move type move. So we can't even test it. So let's just let's add this to our move type place as well. Because we only want to do this if we're in a move type place or if we're in a move type move and movement event 1. So we'll just place this where we were going to place it, right here with the correct ternary operator. Right here. I love those things. I just always have to look up how to do them. Okay, now pressing up or down should change it. And it does not. It sucks to have momentum and then get stuck on a freaking ternary implementation. It's not switching move type, man. It's really sad to me. Oh well. We'll just do it, we won't do a fancy ternary operator. We're too stupid to make that work, so we're just gonna say if it's a move type place, then we're now a move type move. Else we were a move type move, so we need to become move type place. Okay. Now, if we have the same code for our move type move, it should work fine. It's just our fancy ternary operator giving us problems. Okay, let's see. Oh God, 240. Okay. Okay. That should work. We're overriding our move type somewhere. Movement event is 1. if it's a move type of move. So yeah, we're not even getting to execute that code yet, because we're not even in a move type move yet. So where else do we... Come on. Where do we assign this? Dude, what the heck is going on? We start in a move type place. What if we start in a move type move? Just to see. Because I want to see if it's getting overridden. No, move type move. So we can swap to a move type place, but we can't swap. Maybe we just screwed up the code for that. So in a move type place, up is pressed if a move type is place. Actually, move type place. This is already in move type place, so we can just say we can only swap to a move type move from a move type place. So we're gonna say move type gets move if up or down is pressed. Let's see if that fixes it. Dude, what is going on? We start move type place. If it's a move type place. No, we don't assign this anywhere else, do we? We shouldn't swap the player here. But this is if you press a mouse stone, so it doesn't. No, yeah, we should swap a player. So see, we don't need to do this because we're already in a move type move. So we just need to say move type gets placed now. But that one was actually working. We just can't swap into a move type move, which is just so weird to me. Gosh, I need the momentum. I need the momentum. Why is it not working? I'm beyond confused. Our move type is place, which it starts out to be. Pressing up or down should play the sound, which it does play a sound, and it should swap to move. So now if we turn off this sound in move type place, does it still make a sound? It does. So it's not this line that's executing, it's the other line. So where are we hitting up or down? Where are we playing this beep sound? Beep. Play. Upon an up being pressed. Should be only other one instance in a move type move. Type move, so why would it make the sound? That doesn't make any sense. We already did this, so this shouldn't change anything, but I don't know what else to try because it's still making a sound on an up press, and that's the only time an up press makes a freaking sound. It's not swapping our move type. What is going on? So if we take this sound off, does the sound really go off? The sound really goes off here, so this line of code is executing when we're in a move type place. Because why would bro, that is so weird. It makes me sick. Why would it be this difficult? What are we doing with our move type? We aren't assigning it anywhere else. Move type gets, let's see, all the places we assign it. We started out, move type place. Cool. If we press up in a move type place, we should swap it to move. Cool, that's not working. If we press it up and we're in a move type move, which shouldn't execute, does execute. That's the only places we assign it. So I have truly zero idea why it's messing up. Literally, let me just see. We're not gonna switch the move type, we're just gonna let's actually make sure we're printing up the right move type. So look, if it's a move type place, we print up move type place. Move type move, we print move type move. Okay. I'm very confused. Let's try to just do sound. So, if we're in a move type place, we press up, a sound should play. Now let's mute the move type move. Let's mute this one. For now, we're just trying to see sound from a move type place pressing up, which isn't working for some reason. It should play a sound if we press up in a move type place. Let's see. Okay, our sound is working at least. Now, if we swap to a move type move, it should not make any sound when we press up or down. Okay, it doesn't. So the sound's at least working. Now, how come when we turn on move type gets move if up is pressed or down is pressed when we're in a move type place? Why does that not go to a move type place? We got to swap to a move type place. So pressing up or down, since we're in a move type place now, pressing up or down should switch our move type to move. It's making the sound. Yo, why is it working now? Let's just keep going. So let's turn these off. Now let's test the sound for this one. If we press up or down when we're in a move type move, and we'll swap this to move. Now, in a move type move, press up or down, should just play the sound and not change our move type. Okay, it is playing. So now let's see if we can swap to move type place. Yes, we can. Now let's put back on our move type place to move type move logic, and we'll see if that's working. They're working individually. Okay, I think I know what's going on. Since we're doing this so early, so for example, we're in a move type place, we press up, it switches to move. That worked, and it didn't work back because now we're in a move type place and up wasn't pressed. I don't know why it's not working. I was gonna try to make up something. What? Why do you not do that? I think we just need to decouple this somewhere. We need to put both of these somewhere else. So I'm just going to take it out of here. Oopsie. Oopsie. Let's just take this. We'll give it our own place right before we do mouse press detection or whatever. We'll do swap move type. So we're going to say if move type is move. Now if we do them in the same spot, I think it might fix our problem. So if move type is equal to place, and then we press up, will be move type move, else, or no, yeah, if move type is place, let's just make sure we take out this one. Yeah, we need to add if movement event is 1 in move type move. So if move type is place and lev is pressed, do that. Else if move type is move. Move type is placed. Then we should swap it to move when we press up. Else if move type is move. Then if we press up, we would swap. What am I doing? We play our sound. Swap our move type. Okay, so this line of code here is now swap move types. Now, we should only do this if the movement order, what do we call it? Movement, what do we call it? We're just working on it. Movement event. If our movement event is equal to 1, because we can't swap to a move type place unless we're in a movement event of 1. Dude, come on. 946. Or if we just know how to add our end statements. Okay, moment of truth. Move type move. We can swap to a place and we can swap back. It's working now. Cool. Sweet. That's looking okay. I'm gonna put this in a collapsible thing. Okay, so we've got move type swaps working. We've got legal moves working. Now we just need click detection upon our legal move to then lock in our movement origin grid row. So let us get working on that. Okay, movement event 1. This is jacked. We don't need this in move type. We need this. This is wild, man. I don't think we want that. Oh, come on, what just happened? Oh, God. Okay, whatever. This is working still, yeah, that should be working still. Let's... What was I just doing? Like, I lost my place so hard. Okay, we deleted this. So this is setting our milestone occupants to 0 if we don't have a movement origin locked, but okay, yeah, we shouldn't have milestone occupants until our second movement event, which makes sense. So if we're in a move type move, why do we get an occupant? Oh, no, I don't think we do. We just get an occupant in a move type place. See our mouse occupants in a move type move, and milestone occupants is 0. And we have 1 in our move type place. So that looks like it's working. Okay. So we need to move. We need to update our milestone members for every mouse. See, I have it here. What we actually need is it here. We need it. Hold on one sec. Let me just copy both of these. If it's a move type move, then go ahead and update our milestone positions, no matter what. then we're saying, how come whatever. Okay, we update our milestone position, then we set all legal moves upon stack control. We render legal move highlights upon a mouse. Yep, and then we set legal move upon stack control. And we render legal move highlights upon mouse over. We already have it. Now we have to detect click detection. So if button equals 1, meaning we left clicked, then if the grid where our mouse is happens to be a legal move, then what we're going to do is switch to movementEvent 2, which currently doesn't have any logic on it, but let's just see if we can click on a legal move, which should be based on stack control at the moment. Come on, dude. It's always this. It's always this. I always just forget. An end. Okay. Yeah, move type move. If we click in a move type move, it should be movementEvent 2 now, which it is. So that seems to be working okay. But what we really want is we want to start on a move type place. And then there's a handful of things we need to do when we do this. So when we lock in a legal move, this is locking in our movement origin grid. So I want to say that right here, this is lock in movement origin grid. That's the bright green highlight. So we want to lock in movement origin grid, which means we no longer want to falsify a legal move highlight if the mouse isn't over it, if our movement origin grid is locked. But the better way to do this, instead of doing it like that based off the Boolean, we're gonna go ahead and falsify it, but we're gonna lock in some variables here for our movement origin grid row and column. And if those are populated, if those are not nil, then we're gonna say go ahead and render our legal move highlight there. And don't falsify it until the move's over. So we're going to lock in movement origin grid, and what that means is we're going to say movement origin row gets locked in at our mouse X grid, and our movement origin column gets locked in at our mouse Y grid. So if the place we click on is a legal move, we're locking in our movement origin grid. We're becoming movementEvent 2. Now we need to let's see what we need to do. Come on, dude, what? Okay, so we click, it migrates the movementEvent 2 it did not nullify the legal move of the space we clicked on. So what we're going to do is say that the grid we clicked on becomes not a legal move. We want to permanently render this bright green because that's the movement origin. So what we're going to do is we're going to falsify it so it's not a legal move anymore, because we don't want to detect any legal moves in that area because it's not a legal move anymore. So we're going to say that the legal move field gets false upon locking in that movement origin grid. And then we want to say that these movement origin grids, movement origin column, and movement origin row gets nil. Upon init. And see, and this is going to throw us off in the debugging because we can't, it'll crash if those are nil. But maybe we convert it to a string. I never tried that actually. If we convert whatever's being nil into a string, I don't know if I've tried that, but we start off as nil. I want to say that when we reset, those become nil too. Origin locked. Movement origin row. Yeah, let's say this gets nil. Movement origins get nil. And then what we're going to do at the end of our update is say, because we're flushing our legal moves, our legal move highlights, it's like we're only rendering highlights based on if we're in a move type, move event 1 right now. But we need to do it for everything, so we can say, here's our legal move highlights. So why don't we render our locked in highlights or whatever we call it. But right now it's movement origin highlight. And we need to say that if movement origin row does not equal nil, then if our movement origin row does not equal nil and our movement origin column does not equal nil, that means we have a movement origin locked, and that means that our grid at our movement origin row index movement origin column, that field's not legal move highlight. No, actually, yeah, legal move highlight gets true. That's the bright green. So instead of debugging and printing up the movement origin row, I think it'll crash. Movement origin row. Yeah, we don't have it. Let's see if this doesn't crash, first of all. Okay. Let's see if we lock in. Right now, our legal move highlight is only true upon hovering over a stack control, but as soon as we click on it, it should just become solid green. Nice. And it's not a legal move if you look. So that's exactly what we want. Now I'm curious if we print up movement origin, any of those movement origin, so I'm going to say movement origin row gets concatenated. No, yeah, I have definitely converted a nil to a string. Maybe we can say only do this if our movement origin. Well, first of all, let's watch this crash. If it does crash, which I'm hunching it will. It really doesn't. It really doesn't. I thought for sure that would crash. So let's print up our movement origin column while we're at it. I'm curious if the OBS is still recording. We're going 2.5 hours, still going strong. So yeah, let's do... It looks like we might be done with our movement event 1 out of 7 after 2.5 hours. I thought I was going to fix this today. So, yeah, movement origin row nil. That's weird that stone control isn't getting populated here. We need to make sure we do that. Nice. So we lock in our movement origin. Cool. So we're populating stack control properly, but not stone control. And that's actually because that tester stone, we aren't putting stone control. Because we don't actually assign these. We have to manually do it here. So stone type, stack control. Not stack control, stone control. Actually, no, we need both. So stack control gets white and stone control. Now let's look in our occupant class to make sure we got both of those. We have stone control and stack control. So we just need to assign stack control. No, we just need to assign stone control. So that'll be right. And then we'll see if, yep, it's getting populated properly now. And then if we drop a stone there, it's also getting populated correctly. Stone control, LS. Oh, stone control is a type, not a color. So white is not right, y'all. Obviously. It is stone control of LS. Okay. I think we're done with movement event 1. So if we're in a movement event 1, pressing left or right should not shift our stone type or make a sound, which it does not. So, and pressing up and down will only swap move types. Doesn't switch anything else. Okay, then when we click on this, movement event becomes 2. I'm gonna add a space to our movement event so I can read that a little easier. So this will be 6, 7, and 8. Okay. We've got move event 1 pretty confidently done. We just need 7 more. Actually, that was gonna play. Okay. Let us condense all of our move type 1. So this is clicked and leave a move. We need to update movement origin row, movement origin column, swap to movement event 2. We do all that. Let's check in our notes if we missed anything. We probably also wanted, no, we don't need to do stack or stone control just yet. Let's check our notes. Where are our notes? set legal move highlights, we do that. We render the legal highlights over mouse over. And then if we click an illegal move, ooh, yeah, we need to place 5 stones in hand. Okay, gotcha. We're not even done with move event 1 yet. Silly me was thinking we were gonna refactor all 7 move events in one episode. So when we copy over our mouse stones, we need to take the top 5 and only the top 5. So if we click, what do? We would need to be able to tell the stack order of the topmost stone, and that will be the first one. So if we have a decrementing for loop starting at 5, we can say we can copy over the stone one at a time into our mouse stone members at the index of our stack order from our grid. So we would copy over from the top stones one at a time, copy it into our mouse members, copy the stone type, the stone color, the stack order, maybe something else, I don't know. But yeah, let's see if we can just copy over the top stone. So once we click, this is movement event 1. Once we click here, we need to pick up these stones. So we get our movement origin. Before we swap our movement event, we're going to say that our grid at where our mouse currently is, come on, we're going to say that that member's top of 5 stones. Geez, yeah, how do we do this? Let's just try to do the first stone first. So we're gonna say that there's a for loop for actually, I'm not sure how to do this. Yeah, for many, maybe we can say if the, because we want to do something 5 times or less. And depending on how many stones are in our occupants, defines how many for loops we're going to need, I think. So we can say if occupants, if our current occupants are less than 5. No, I don't know what I'm trying to do here. We're just trying to copy over the top 5 stones. So we start at the index. Yeah, we start at the index of whatever the highest stone is, and we only copy over 5 stones. If it's nil, we break. So we need to say something like where I gets how many occupants we've got. comma, starting at the stack order. Wow, really tough. We're trying to copy each member one at a time. So we want to do a for loop of what, 5? We only need to do it here. I'll tell you what, we'll do it. We'll say if our mouse stone occupants just, gosh, damn it. If our grid's occupants is greater than 5, we want to copy over 5 stones. So okay, so the stones we want to copy over is we want to copy over 5 stones, and we want to start at the grid at index. What do we do, man? We want to copy over the highest member. How do we get the highest member? We do a loop where we say for however many occupants you have, you're gonna for I gets 1, for as many occupants you have, we are gonna do something that is going to copy over each of those occupants, but we only want to copy over 5. So we're going to say do something for 5. Now we need to figure out the index. Yeah, we need to figure out the index of our 5th stone from the top. So how do we do that? Well, we take however many occupants we have, and we subtract 5. So if we have 10 occupants, then our bottom stone will be the 5th occupant, because then we'll have stone 5, 6, 7, 8, 9. So we actually need to minus 4. So 9 stones minus 4 would be 5. So we're saying move over 5 stone. We want to start at top. Oh, it's tough because the stones are organized by stack order. So we need the highest stack order, not the occupants minus 4. Yeah, highest stack order would just be the amount of occupants we've got. So if we are going yeah, I think what we want to do is let me just see. We're trying to copy over 5 stones. Okay. Now, what that means is we need to take the highest member stone. So it's a dot members. At our occupants index, because that'll be our highest mouse stone. So what we're going to do with our highest mouse stone in our grid is we're gonna copy that mouse stone into, copy that stone into our mouse stones location at the very same stack order index. So in our .members, at our index of whatever this occupants was. So we are copying over, and we don't want to copy over just that member. We want to copy over things from that member. We want to copy over the stone color into the stone color field so we can render that. And then we also want the stone type. Stone type. And then we also want stack control. We copy over stack control. No, not stack control. We just need the stone, no, stack order. That's what we want. Because we want to keep track of that stack order. Okay. And then what we need to do is decrease the occupants. Decrease the occupants from our current grid that we're in. So we decrement that, and we increment the occupants of our mouse stone at, okay then, here. We say milestone members at our current occupants dot occupants, because occupants is part of our occupant class, which is just our mouse stone. So we need to say, that the dot occupants is just here on our mouse stone. Dot occupants needs to increase by 1. Now we also, no, I think that might be okay. So let's see if this, actually this should copy over 5 stones, but we need to nullify the stones that were in our mouse grid. So we need to now say we need to nullify these values now that we've copied over the values. We need to nullify each one, so we need to nullify this. We need to nullify after we copy it over. Come on, dude. We need to nullify that. Okay. So we nullify the stone color from our mouse grid, so it's no longer there. So we copy it over into our mouse stone. We wipe out, we delete the one in our movement origin grid. Then we increment our occupants of our milestone, and we decrement our occupants from our movement grid. But we need to nullify stone type and stack order in that member as well. Okay. Yikes. Okay. Now let's see if we pick up 5 stones. We do not. It says we've got stack order of 6. Stone occupants 1. If we're in a move type move, our stone occupant needs to be 0 if we're in a move type move. Needs to be 1 if we're in a place. So milestone occupants if we're in a move type move. Do we set occupants equal to 1? I don't like that we do this here. No, this makes sense. God damn it. Okay, let me just see where we've got milestone occupants. I always do moused. Okay. We should be... If we're in a move type place, sure, our milestone occupants is 1. That's where we're doing it. Otherwise, as soon as we're in a move type move, we're milestones 0. So we need to say milestone occupants get 0. If we're in a move type move. No. I guess we'll do that if we're in a move type move, movement event 1. No, because we want to override it, so we want to say something like this. If it's a move type move, we initialize our milestone occupants to be equal to 0. And then that'll only increment once we click right here on a stack. So let's see, we should have 6 milestone occupants upon clicking now. We don't. Milestone occupants are 0. Milestone occupants gets incremented here. And then I think we're overriding it here. Oh. Okay, I got an idea. We just... You know what? We don't need this. We just say mouse stone occupants. Even though it's wrong. We'll just populate it. Here, we'll take this off. Because we're not placing it based on if there's a mouse stone occupant. We know if it's a move type place, we're going to be able to place it. So we're just going to initialize mouse stone occupants to 0. In our reset, our mouse stone occupants, it'll get 0. So now it should be 0 on a move type place, which it does have an occupant, but we only really use mouse stone occupant logic for our move type move. So now we technically have 5 stones in our hand. Now I couldn't tell you why we're not rendering them. But I think where did we render mouse stones? Renders mouse stone selection. Okay. So yeah, we should be rendering each member of our mouse stone. Oh, but look, and movement origin locked. Bye-bye. We need to instead say, and if it's a move type move, and we're at a movement, gosh, what do we call it? Movement order, movement stage? What do we call it? I keep forgetting. Movement event, that's what it is. Movement event is equal to No, yeah, that's right. So now we should be actually rendering them. Let's see. We'll need to add the sound as well. Nice. Now we've got 5 moves, 5 stones, and their stack order. At least we should. So one thing we need to do is, oh no, we're still doing stack control. Oh, but look, stack control says white, which is wrong. Stack control needs to get updated as well. So when we click here, before we switch to movement event 2, we need to update stone control and stack control, because we have moved members out of a stack. So we're going to say update stone control, which takes in a occupant, I believe. Does it take in an occupant? Yeah, it takes in an occupant, and it'll update your highest members. It'll update your field to your highest member of that field. So the occupant we want to give it is, we want to update the grid that we just clicked on. So now that we're doing that, let's check stack control once we take 5 out of a stack. And now stack control is black. Stone control is laystone, so that looks like it's working. But we need to do another thing, which is we need to copy these stones if we have less than 5 occupants. So if our grid, this is actually, yeah, this is weird. If we have 5 occupants, or exactly, if we have more than 5 occupants or 5 occupants, we need to copy over 5 stones. So I'm curious what happens if we try to copy over everything. In that stone. Yeah, let's see. So let's do a 5 stack, right? So we need a 5 stack right here. We should be able to take all 5 out of a 5 stack. So we're gonna say that our occupants here at grid 3-3 is now equal to 5. And we should be able to take all of those stones out, leaving nothing in our green space. And we are able to do that. I'm curious what happens if we move this. If we comment out what happens if we try to copy over 5 stones when we only have 4 stones. Because we're about to code that logic. I just want to see what happens if we only have 4 stones. Okay. It doesn't take out any, which makes sense. Okay. I'm gonna take this off. Well, actually, no, we're gonna leave that on. We're trying to copy only 4. So let's go back. Dude, we're still on movement-event 1, but this is going so much more smooth. Like I feel so much better about this way to do it. Because then we can just like, here's all our movement-event 1 logic, you know, boom, right there, all together. So here, else, meaning copy over less than 5 stones. Now we need to do a for loop of only the amount of occupants we've got. So we're gonna say for I gets 1, comma, however many occupants we got. That's how many, that's how many for loops we're gonna do, because we only want to copy over the amount of stones we actually have. So this would be copy over stones in grid. This would be less than 5. Copy over less than 5 stones in grid. We're just going to say less than 5 stones. This one copies over 5 stones. This one copies over less than 5 stones. Because we can't go index any nil values, I guess, or we got to split this up. So if we're less than 5 stones, we're gonna do a for loop for the as many occupants as we got. See, now this is actually not a good idea, because we're gonna be modifying our occupants in this logic. So we don't want to be doing something for that amount of times, but what we can do is say that we lock in our mouse stone occupants. We move that into a variable that we can go ahead and say is stones to copy, and we assign the number of mouse stone occupants into our variable stones to copy only once upon a click detection and a grid being less than 5 occupants. Then we do something a stones to copy amount of times. That way, when we decrement our mouse stone occupants in the logic here, actually when we increment it, we're not actually changing our for loop to make it infinite. So we're locking it in at a hard-coded mouse stone occupants value, but then we're going to be modifying that value without modifying our for loop, which is what we want. So what do we want to do? We want to do the same thing. Except for here. Let's go one by one. So what we're doing is copying over the member. We want the member of our highest index, right? Which is the current amount of occupants. That should be right. And we want to move that into our mouse stones. So I think this is okay. I already feel bad about copying this, but I don't know what to, I don't know how to do the for loops different. I don't know how to do the for loops different without them crashing. So we're going to do the same thing where we copy over from our grid into our mouse stack order at the highest member first. Then we're going to nullify all of our values from that grid, from that original grid, not our mouse stone grid. Well, yeah, there's no grid for our mouse stone. But then we're going to increase our occupants, and then we're going to decrease our grid's occupants. Now, even though these are the same lines of code, is there a way to do this where, yeah, okay, I got an idea. We need to basically just do this, where if our mouse stone occupants are greater than 5, we need to update this stones to copy by 5, because we can't copy more than 5. So we can do that. We can say, if we have more than 5 occupants, then our stones to copy is 5 stones to copy. And we say, otherwise, our stones to copy is actually the amount of mouse stone occupants we have. Okay. Yes. Then we just do one for loop a stone copy amount of times. So, and it's not mouse stone occupants, it's this grid occupants. Now, we need to initialize this so it's not garbage. We'll do it here. Stones to copy gets 0. And upon a reset, we also flush it. Now, now we just do something, stones copy amount of times, stones to copy amount of times. So we get how many stones to copy on the mouse press. And then we copy over the amount of stones to copy, that makes sense. And we copy it over, we nullify the old ones, we increase our mouse occupants, we decrement our old occupants. Then we update our stack control, stone control, change movement event. So let's see if we can copy over 4 stones now. Yep, we copy over 4. Perfect. And we can copy over more than 4. Let's test that though, because we did change that code. Look at how much nice that is. We don't have to repeat ourselves. Let's turn off this and this. Let's go ahead and try to clear. Come on. Let's try to print or take 5 out of a 10 stack. Let's see. Looks like it. So it looks like it's working. I didn't check one stone occupant, but I did check under 5 and over 5. So it seems like our new code is just working better for that. Or we're actually working for that. Cool. So that looks like we're done with our movement event 1. I think that means we're done with movement event 1. I'm going to make sure our stack control, stone control is still setting right. White stack control, yep. Yep, stone control, please stone. Sweet. So if we go over here, and we minimize this, now check that out. Now we can look at our branching stuff instead of trying to do all this old shit where we were asking it based on these booleans. If we've got not first movement stones dropped, but first movement grid locked, we don't have to do any of that. Now we just cycle it through the movement events, and there's only a certain amount of things we can do for each movement event. So this one is legal moves and highlights. So look, we can say this is legal moves and highlights, and we can collapse this if we want, and then we can say this is mouse press detection or whatever. This is locking in movement origin grid. So we can say this would be locking in movement origin grid. Movement origin grid. And then nice. So now we can even actually I don't know why we can't collapse this, but that's okay. I think maybe it's because this is here. Maybe if we have this one more line in, we can actually, no? No? You can't even close it. What the I don't get how these work all the time. Well, now we can close that. And we can say, yeah, you know what? I think I want all this to be indented one, so that we can minimize this. And minimize this. And minimize this. Nice. So now we can open this. See all that good stuff. Cool. I don't get why if we open this, or we close this, then open this, it expands again. But I don't know, it just depends on how we want to do it. Now I'm not liking that it goes in too many indents. I like it when it's the right amount of indents. And now okay, well, okay, I like that. We just can't collapse that one, but that's perfectly fine. Legal move highlights. Cool. Yo. We got 1/7 of our movement logic done, refactored today. I was a bit ambitious, thinking we were going to get through all 7. But we put a game plan together, came up with the amount of movement events, and then we at least fixed one. And it's so much easier. I like it a lot better than what our old method was. It's very much easily expanded compared to the other one. Now, I'm just going to fly through the git diff so you guys can see, but I'm not going to really talk over it or explain it. I'll talk over it. We added all those movement events in our notes. The biggest thing we did was take out all of our move type move logic from our old move type move logic. We commented all that out, and then we started implementing this new flowchart based update to those things, which is much easier to look at and maintain. So this is a big commit, and there's a lot of weird shit, but we removed functionality, basically. We just made it better. We refactored. We had up to movement event 4, I think, but we refactored everything, and we're re-putting it together from scratch, and we're only at movement event 1 yet. But that's okay, we'll keep going. And this is much better anyway, so. Once we're done with this, once we refactor all that, we'll have to go through and make sure any of these that aren't being used, once we delete all our old code, gets deleted, so we don't have any extra stuff floating around. But we're making good progress. It was a tough refactor session, but we've got the template to make it work now. And all we got to do is just redo all our old stuff, just a tiny bit better. It's a much better way to do it. Okay, I think I'm ready to commit. So, okay, what do you want from me? Get add everything to the staging area with a commit message saying we refactored all move logic, finished, or I'm going to say refactoring all move logic, finished movement event 1 logic. And we're going to get push before midnight. I'll see you guys tomorrow. Hopefully it's going to be another long session like this, depending on my work. But I'm going to try to get a bunch done tomorrow, just like I got done today. So I'll see you then, and we'll make some more progress.